Welcome to our Stoichiometry class. This is the continuation of part 1. Again, this is gifted aka Izu, first in Africa, sixth in the world. We've done example 1 and example 2 in the part 1. We are looking at example 3 here now. The question is, what mass of lead 2 triazole will be required to yield 9 grams of lead 2 chloride on the addition of excess sodium chloride solution? As usual, the first thing to write out is the chemical equation. This is the chemical equation. The next thing I'm to do is to mark out what I'm asked to obtain, the required. Here, what mass of lead 2 triazole? So I'm required this. This is what is required. And what is given to us is lead 2 chloride. So this is the given. This is the given. So I'm comparing between these two substances. Okay, again, I'll be splitting my board into 2. And now the first thing to do is to write out the moles of what we're asked to get. Here I have 1 mole of this, 1 mole of PbNO3. NO3 is required to get 1 mole as well of PbCl2. And so that's that about that. Now, the next thing is what is given to us. We are given 9 grams of lead 2 chloride. So 9 grams. So mass of PbCl2 is 9 grams. So I need to get the mole of that. First of all, what's the molar mass? Molar mass of PbCl2, lead 2 chloride. That will give us, lead is 207 plus chlorine is 35.5 multiplied by 2 now. So at the end of the day, I will have 207 plus 71, 207 plus 71, and that will give us 278 grams. So the mole of lead 2 chloride, mole of PbCl2, is just equal to mass over molar mass, and the mass is 9 over molar mass 278. So that will give us 0.0324 mole. That's the answer. So I'll just come here and write that the yielded mole of lead 2 chloride is actually 0.0324 mole. So the question that comes to us is, what mass of lead 2 triazole? Obviously, you see 1 mole of this gave 1 mole of this. So obviously, 0.324 mole of lead 2 chloride is what is yielded. Then it therefore means that it is 0.0324 mole of PbNO3 that must have been used to yield that same thing. Since 1 mole give 1 mole, this will give this. So easily I can see that the mole of PbNO3 is 0.0324 mole. But that's not what we're asked to get. We're asked to actually get mass. So what do we do from here? We've gotten mole already. Yes, so at the end of the day, we can come again to say that molar mass of PbNO3 is actually, Pb is 207 plus nitrogen here is 2 because of the 2 here. That's 14 now times 2 plus oxygen now will be 16 times 6 because of the subscript 2 outside the bracket. So times 6, 16 times 6, sorry. So at the end of the day, we would have 331 gram per mole. So I'm asked to get the mass of lead 2 charge 5. So I can say that mole, as usual, is mass all over molar mass. And now the mass is just simply the mole times the molar mass. So the mole we've gotten already is 0.0324 multiplied by the molar mass. And the molar mass here is 331. So at the end of the day, our answer is, so that's about that. So this is the final answer. Example 4. The example 4 says, how much magnesium is required to react completely with 100 cm cube of 0.1 mole per dm cube HCl? Well, quite an easy one here. The first thing, as usual, again to write is the chemical equation. And so that's this equation. And then the next thing is to mark out the two substances we are comparing. Here we have how much magnesium. So I'm asked to obtain magnesium here is required to react completely with HCl. So this is the HCl given to us. This is the given. So that's all here. I'm going to divide my screen to 2 again. Quite an easy one. Here I'm giving 100 cm cube. So I'm giving volume. 100 cm cube. I have to convert to dm cube, which is 100 all over 1000, which is 0.1 dm cube. The next thing again is I'm giving concentration, because this is a solution. Concentration, which is equal to 0.1, okay, mole per dm cube. So I'm skipping something here. The first I'm supposed to write is 1 mole of magnesium, 1 mole of Mg requires 2 mole of HCl. Okay, so this is the first thing I'm supposed to write. Now, from what is given to me, I can get the mole. Mole here is concentration times volume. Concentration times volume. The concentration is 0.1. The volume is also 0.1. So this will give us 0.01 mole. Yes, so that's the mole given to me. So I'm going to write that down. That the mole of HCl given to us is 0.01 mole of HCl. That was the question given to us. So the question now becomes, how many mole of magnesium do we have or is required? We don't know that. We can call that X. You can easily cross multiply this reaction. If you cross multiply, this goes for this, and why this goes for this, you can get what you are the X you are looking for. X, that will give us X times 2 is equal to 1 multiplied by 0.01. So at the end of the day, X is equal to 0.01 all over 2. This will give us 0.005 mole. And so I can say the mole of magnesium is 0.005 mole. If I've gotten the mole of magnesium, I can easily get the mass of magnesium. So the mole of magnesium is 0.005 mole. From our relationship, mole is equal to mass over molar mass. Mass will be equal to mole times molar mass eventually. And the mole has been gotten as 0.005 multiplied by the molar mass of magnesium. That's given in our question as 24. So I'm going to use that here, 24 times 0.005. So that will give me 0.12 gram of magnesium. So that's about that. Thank you and God bless you.